My name is Mr. Tierney, and today I'm going to give you the first video lesson in the course of Introductory to Algebra. And I want you to have a little bit of background real quick about the word algebra and what algebra means and what type of math algebra is, how it's different from the type of math that you guys may be used to and have done in the past. Well, interestingly, the word algebra is actually Arabic. It means the reunion of broken parts. And that may seem kind of cryptic or a little bit weird to you guys, but actually it makes a lot of sense once you get doing algebra problems more and more. Algebra is sort of the math of putting stuff back together. And you'll see that a lot of algebra problems are very similar to solving puzzles. They're very close to if you were to take a jigsaw puzzle and find different pieces to move them around and make the pieces fit together. Algebra is sort of like taking all those pieces of a puzzle and putting them back together into something that means something. So basically though, even though the Arabics are credited with the word algebra, and are sort of the civilization that named this type of math called algebra that everybody has to study today, it was actually the Babylonians that first developed algebra. They were the first people to come up with the very most crude, basic forms of algebra, and the way they did that was they solved quadratic equations. They were very interested in solving lengths of sides of a triangle. But then after the Babylonians did a little bit of introductory work in algebra, the Greeks and the Egyptians later took their work and expanded on it. And then today we have this wonderful course called Algebra that you and I are going to study together. So first thing I want to do is I want to recap what you guys know and what you guys have studied recently in your previous math classes. And basically what you guys should have covered were the four basic operations of mathematics. You've got multiplication, which would be something like 2 times 2. You have division, which might be 5 divided by 3. You have addition, 10 plus 2. And you've got subtraction, say 7 minus 4. And these are all really nice. They're pretty easy once you practice math for a while. They're very easy to compare this type of math to real life examples. For example, I have 2 apples and I want to double the number of apples I have. That could be 2 times 2. Okay? Or I have 10 birds and I buy 2 new birds. That would be a great example of 10 plus 2. But algebra gets a little bit harder. Some examples of an algebraic equation would be 5x minus 3 equals 4. Or, for example, 7y plus 9 equals 42. And so the biggest thing that you guys should notice that is the difference between the math that you guys have studied before, addition, subtraction, multiplication, division, is that these algebraic equations have letters in them. And you're going to look at me and go, oh my God, Mr. Tierney, what are you talking about? There's no such thing as letters in math. A letter's not a number. You're not quite totally 100% correct there. These letters are a very, very special part of algebraic equations, and they're what make algebra equations algebra. If we didn't have these letters, it would just be a regular addition or subtraction problem. And do you remember how I was talking to you earlier about how the Arabs named this branch of mathematics the reunion of broken parts? Well, what we're going to do is these y's, these x's, these letters have broken up these numbers on the side of our equation. And our job is to somehow put all of these numbers back together into an easy to read format. And what we're going to do to learn how to do some of these basic algebraic equations today is we're going to do a scale activity. And then we're going to cover some of the more basic practice examples for you guys to go through, and then I'll give you some to work on your own. Now, real quick, before we get started, I want to rehash one real important thing with you, okay? If you look at this algebraic equation up here, you'll notice that it has an equal sign in it, which you're pretty familiar with. You've used equal signs before in things like addition. 2 plus 2 equals 4. Or multiplication, 5 times 5 equals 25. Maybe division, 35 divided by 7 equals 5. Okay, but I don't know if maybe you forgot or if you even ever have thought about it before, what that equal sign really means. Okay, so think about real quick to yourself, what does it mean for that equal sign to be in these equations? Pause the video for about 10 seconds, think about it, come up with an answer, and then we're going to talk about it. Okay, so what this equal sign means is that no matter what, each side of these equations are exactly the same. Both sides of the equations have the same value. That's what the equal sign means. 35 divided by 7 is always going to have the same value as 5. They're equal to each other. 5 times 5 is always going to have the same value as 25. 5 times 5 is always going to be equal to 25. Okay, and likewise, even if we don't know what this x thing is, what this weird x is, how much it's worth, we may not know, is x worth 25? Is it worth 100? Is it worth 6? Is it worth -2? Who knows? But we know that no matter what, however much x is worth, 3x plus 4 has got to have the same value as 9. It's got to be equal to 9. Okay? So what the purpose of algebra is to figure out what this x is going to be worth to make both sides of the equation equal. Okay? And so what we're going to do is we're going to come up with some ways that we can solve for this value of x to make these sides of the equation equal. Now, I want you to think real quick about a real-life example that you can think of in which two things must be equal to each other. And the first thing that comes to my mind when I think of equality is a scale. I think of two sides of a scale, and I put things on either side of the scale, and they're in balance with each other. But then, the minute I take one thing off of one side of the scale, the other side sinks to the bottom, and they become unequal with each other. So no matter what, in a scale, what I have to do is I have to keep the exact same amount of stuff on either side of the scale to make it equal. And equations and algebra are exactly the same. No matter what, the exact same amount of stuff has to be on either side. Otherwise, it's not an equation anymore. What I want you to do is I want you to imagine now that I have a scale, okay? And I took, on this side of the scale, 15 blocks, and I put them on this pedestal. So I have 15 blocks on this side of the scale. Over here, I have 3 containers that I'm going to put some blocks in, and I labeled them X. And if you put 2 and 2 together from the earlier part of the lesson, you'll notice that these X's are going to represent the X's from the algebraic equations that we had previously talked about. So my question for you is, if I have 15 blocks on this side of the scale, how many blocks am I going to need to add to this side of the scale to make sure that they're in balance with one another? Pause the video real quick, think about that, come up with an answer, and then play it again and we'll talk about it. Okay, so if you answered that we need 15 blocks on this side of the scale to make sure that they're in balance with one another, you are absolutely correct. Remember, if we're going to balance this side of the scale over here, we have 15 blocks on this side of the scale. We are going to need 15 blocks on this side of the scale too. Otherwise, they're going to be out of balance. If I have 15 blocks on this side of the scale, but I only have 14 blocks on this side of the scale, then this side of the scale is going to go down, and this one's going to go up, and they're not going to be in balance with one another. So the interesting question that I have for you is, how can I make sure that I put an equal number of blocks out of my 15 blocks into each of these cups? Okay, because if I have, for example, 7 blocks in this X, and 6 blocks in this X, and 1 block in this X over here, then they're all going to have different values. And so then this isn't really going to be, this X isn't going to be the same as this X, and this X isn't going to be the same as this X, and so then labeling them really means nothing. So we need to make sure that each of these cups has the same value of blocks in them. Well, one way I could do that is I could take blocks one by one, and I could put them into each cup. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So by counting off one by one, I was able to determine that I needed 5 total blocks in each cup in order to get the same amount of blocks in each of these cups for a total of 15 blocks. Now the problem with that method is that if I had, say, 200 blocks on this side and 3 cups, I'd be counting forever. I would literally be here all day long. So that's a very inefficient way of determining how many blocks I need in each cup, and it's also really boring. So what we're going to do now is we're going to figure out a way that we can easily figure out how many blocks must go in each cup for really big numbers. Now what we're going to do is we're going to make our first algebraic equation. Okay, so what I want you to think about first to start this equation off is we have a number of x's over here, and we have 15 total blocks on this side, and that's going to be equal to the 15 total blocks on this side. So quickly pause the video and think in your head, how many x's did it take to equal 15 total blocks on this side? Pause the video and then we'll talk about it. So if you said that it took 3 x's to equal 15 total blocks on this side, you're absolutely correct. And the way that we would describe that with an algebraic equation would be like this. 3x equals 15. Fantastic. The problem was, it took us a really long time to figure out how many blocks were in each x. So what we are going to do is we're going to come up with a quicker way of doing that. And I'm going to start by emptying my blocks out. Now, just like before, what I had to do was, in order to make sure that each side of the scale was in balance, if I had 15 blocks on this side, I still needed 15 blocks on this side. Okay? And I know that what I have to do is somehow I have to fit all of these 15 blocks into 3x's, right? So what I can do is, you see here that I have a stack of 15 blocks. And what I'm going to do is I'm going to divide that stack of 15 blocks into 3 groups so that I can fit my total 15 blocks into 3x's. And the way that I would describe that with my algebraic equation is that I would take my 3x's on this side of the equation that I had here. I had 15 to start, and it took 3x's to equal 15, and I'm going to divide them by 3. And mathematically, what I'm doing is I'm taking 3x and I'm dividing by 3 on this side. Now, just like any other scale, okay, if I want to make sure that both sides of my equation are balanced, then what I have to do is, if I divide this side of my scale by 3, then I have to divide this side by 3 as well. So whatever I do to this side, I have to do over here, and since I divided by 3 on this side of my equation, I have to divide by 3 on this side of my equation as well. And now, if you remember, 3 divided by 3 is equal to 1, right? So that simply becomes 1 times x. And if you remember from your basic multiplication skills, 15 divided by 3 is equal to 5. Okay? And 1 times x is just equal to x. So I know now that x equals 5 blocks, which is a lot faster than what we were doing before, where we were putting 1 block at a time into each cup. The next thing that we're going to do is a little bit of a twist on the last activity. You might be thinking to yourself, well, gee, that was really easy. I mean, I was hoping to be challenged a little bit more by these videos and watching these. Well, don't worry, this one's going to be a little bit harder, because unlike last time where we took 15 blocks and we put them in cups, this time what I've done is I've put paper over our cups, and underneath each of these cups I have put a certain number of blocks, but I'm not going to tell you how many blocks I have underneath each of my cups. Okay? And likewise, I've put 12 blocks over on this side of my scale. And what I want you to do is, on your own, pause the video real quick, and on a sheet of paper, or if you want to, you can find blocks of your own, try to figure out how many blocks are underneath each of my cups. Pause the video and then we'll talk about it after. Okay, so as you know, we had 12 blocks over here, and we have 3 cups labeled X. Okay, so how many X's is it going to take to equal my 12 total blocks? It's going to take 3 X's to equal my 12 blocks. That much we know. So we can start off and say 3x equals 12. Seems simple enough. Okay, but then the next thing we've got to do here is we've got 3 X's, but then I have 4 columns over here. So we need to rearrange these so that I have 3 columns to match my 3 X's, right? So let's take these 3, we'll redistribute them on top, and now I have 3 columns and still 12 total blocks. And we know that there's got to be 12 blocks underneath these cups, right? Because they have to be equal. So what am I going to do? Well, I need to divide my 12 total blocks into 3 equal groups of X, right? I'm dividing my 12 total blocks by 3, so that means what I'm doing in my equation is I'm dividing this 12 by 3, right? And now, likewise, what I do to one side, I have to do to the other side. So if I divide my 12 by 3, I've got to divide my 3x divided by 3. Okay. And just like before, 3 divided by 3 is equal to 1. So I know that this actually equals 1x. And 12 divided by 3, unlike last time where I had x equal to 5, 12 divided by 3 is equal to 4. And 1 times x is just equal to x, so x equals 4. And let's check if we're right. Indeed, underneath each of these cups, I have 4 blocks. So nice job. So this time what I'm doing is I'm giving you a little bit of a more difficult scenario than the previous 2 examples. What I've done this time is on the left side over here, I've got 8 total blocks, and over here I've got 3 cups with blocks underneath them, and like before, I'm not going to tell you how many are underneath them, but this time I have 2 blocks on top that are outside of the cups. So what I want you to do is I want you to pause the video and see if you can come up with an equation for each side of the scale that determines the number of blocks that are on each side of the scale, and I want you to try and solve it on your own to see if you can figure out how many blocks are underneath each of these cups. Okay? And lastly, what I want you to do is I want you to think about how could you figure out a way with your hands. If you were up here and you were me, how could you figure out a way that you could determine how many blocks are underneath each of these cups without lifting them up? So pause the video, give it a thought, write it down on a sheet of paper, and see if you can find the answer. Okay, so the first thing that you need to do is you need to come up with an equation, okay? How many x's are on this side of the equation? Well, we know there are 3 x's on this side of the scale, just like before. And over here we have 8 total blocks. So we can start out by writing 8 on this side of our equation. And like before, we've got 3 x's, right? But then what about these extra 2 blocks right here? Well, we can say that we have plus 2 extra blocks outside of our cups, which is pretty nice, pretty simple, right? Now, here's the thing, right? Before, what I did was I tried to turn this side where I have these number of blocks, I would try and rearrange them such that I would have the same number of columns as I did x's over here. And I have 3 x's, so I need to make 3 columns. So I'm going to take these 2 away, and I've got 3 columns, but the problem is I can't put these blocks evenly into my 3 columns. Well, one thing I can do is I can manipulate each side of my scale. Okay, if I take off these 2 extra blocks, then I can take off 2 blocks over here. Simple. And now I have 3 even columns, which is just what we wanted. Okay? And the way that I mathematically signify taking off these 2 blocks is I took 2 blocks off this side over here, so that's minus 2. And I took 2 blocks off of this side over here, so that's also minus 2. So a plus 2 and a minus 2 cancel out. Positive 2 minus 2 equals 0. Okay? And 8 minus 2 equals 6. So I'm left with 3x equals 6. Okay, and like before, I've got my 3 columns here. I divide up my 6 total blocks into 3 columns. So I divide both sides by 3. Okay. Just like before, 3 divided by 3 is equal to 1. So I have 1 times x equals, and 6 divided by 3 is 2, so 1 times x equals 2, or x equals 2. And let's check underneath my cups to see if that's the case. And indeed, I have 2 blocks under each of my cups, which is perfect. And so really it might have seemed like this was going to be very confusing at the start, because I had those 2 extra blocks on the outside of my cups, but really it was quite simple. Okay, so real quick, what I want you to do is I want you to try this problem, 5x plus 3 equals 28, all on your own. Use a sheet of paper. So what we need to do is we need to subtract this 3 away from this side to start us off. And again, it's an equation, so if I subtract 3 from this side, then I also need to subtract 3 from this side. Now a positive 3 minus a 3 is going to cancel and give me 0. And 28 minus 3 equals 25. So I have 5x plus 0 equals 25. Or 5x equals 25. Because anything that you add 0 to is simply itself. So then what I need to do now is I have 25 total on this side. And I have 5 x's. So I need to split this 25 up into 5 different x's. Or another way of saying that is that I need to divide this 25 into 5 x's. Divide this 25 5 times. And again, it's an equation. So what I do to one side, I have to do to the other side. So I'll divide by 5 over here as well. Now, 5 divided by 5 is just going to give me 1, right? Because 5 over 5 is 1, so 1 times x equals, and then 25 divided by 5 is equal to 5. So 1 times x equals 5. Okay? And we know that 1 times x is just x, because anytime you multiply something by 1, it's just itself. So we know that x equals 5. So one thing I want to do here real quick before we move on is I want to talk about a quick way that you can check your work when you're done solving for these algebraic equations. Because it's helpful to be able to solve these equations, but sometimes you may not be totally confident in your abilities, and it's good to be able to go back through and look at your work and make sure that you did everything correctly. Now the last problem, we had 5x plus 3 equals 28, and we said that x was equal to 5. Okay, great, but how can we know when we're done that x really was equal to 5? That x equals to 5 is the correct answer? Well, it's simple, really. You just plug x equals 5 back into your original equation. So we do 5 times 5 plus 3 equals 28. And now we know that 5 times 5 is equal to 25. So we can say that 25 plus 3 equals 28. And 25 plus 3 is 28. And we know that 28 on this side of the equation must equal the same value on this side of the equation, and it does. 28 equals 28. So we know that our algebraic equation was solved correctly, because at the end of the day, both sides of our equations came out to be the same thing. Now real quick, what I want to talk to you about before we move on to our next example is that if you've noticed, the last example we had, we said that x was equal to 5, right? And before that, we said that x was equal to 2. And before that, we said x was equal to 3. And in our very first example, we said that x was equal to 5. And so you've noticed, even though we're using the same letter, this x thing here, its value is changing. The first time x was 5, the second time x was 3, and then it became 2, and then it ended at 5 again. So it changed every time. Another way, or another word for change, is to vary. X varies depending on how the equation changes, right? So this is why we call x a variable. It has a special name. We call it a variable because x is able to change. It varies. Okay, now try this new problem on your own again. 0.5x plus 2 equals 30. Write it down on a sheet of paper and try and solve it on your own. Pause right now, give it a try, and then unpause it and we'll go over it when you're done. Okay, so the first thing that we need to do here is just like before, we've got this extra 2 over here. So what are we going to do? We're going to subtract it. Minus 2, and again it's an equation, so I subtract the 2 on this side. That means I need to do the same thing to the other side. So I got to subtract 2 over here. Okay, so I get my 2's cancel because positive 2 minus 2 is 0. And then over here, 30 minus 2 is going to be 28. So I get 0.5x equals 28. Okay, and now 0.5 is a half. And it's kind of hard to visualize what we need to do maybe if we leave it in a decimal form. So what I'm going to do is I'm going to rewrite this. And I'm going to say 1/2, because 1/2 is the same thing as 0.5, x equals 28. Okay. Now before, what we've been doing with all of our problems is we've had something like 5x equals 28. We divide by 5 on both sides, and that's all well and good, but now this time we have a fraction in front of our x. So pause the video real quick and think about what you would do to get this 1/2 away from the x. Okay, so what you should do is, I've got this 1 here, right? And I like that 1. I want to, at the end, have 1 times x. But I need to get this 2 away, right here. So if I multiply by a 2, though, then I have 2 divided by 2, and my 2 is going to cancel. I'll just end up with a 1. So that would work out pretty nicely. And again, it's an equation, so if I multiply by a 2 over here, I've got to multiply by a 2 on this side as well. And so then I end up with 1x equals 56. Because 28 times 2 is equal to 56. So real quick, let's check over our work from the previous problem. We solved for x and we said that x was equal to 56, so let's check our work. And the way that we do that is we substitute x equals 56 into our algebraic equation. So we're gonna put in here 0.5 times, we said x equals 56, plus 2 equals 30. Well, if you crunch in on your calculator, 56 divided by 2 is equal to 28. So we get 28 plus 2 equals 30. And 28 plus 2 is, of course, 30. So we see that 30 equals 30. And because both sides of our equation come out to be the same thing, we know that we solved our problem correctly. And x does indeed equal 56. Okay, the last example that I'm going to give you guys to try on your own, and I'm going to go over with you, is negative 8x plus 2 equals 66. Now this problem is a little bit different than before because we have a negative out in front of our 8. Okay, so this is going to be a little bit different, but altogether not too complicated. Try it on your own, pause the video, and see if you can solve it on a separate sheet of paper. Okay, so the first step that we need to do is, of course, subtract 2 from this side of our equation, just like before. So positive 2 minus 2, and that's going to give us 0, because the positive 2 and the negative 2 cancel. And it's an equation. So since we subtracted 2 from the left side of our equation, we need to subtract 2 from the right side of our equation now. And we'll end up with negative 8x equals 64. Okay. Well, now what we're going to do is we need to isolate this x, right? And so what we've got to do is we've got to divide negative 8x by negative 8. And likewise, this is an equation. So if I divide by negative 8 on this side, I also need to divide by negative 8 on this side. Okay. And so what we're going to get is negative 8 over negative 8 equals 1. So I have 1 times x, and if you're confused that negative 8 divided by negative 8 is equal to 1, well, the negatives are going to cancel each other, right? If I have a negative 1 over a negative 1, it's still equal to 1. And likewise, 8 over 8 is equal to 1. So this is going to be 1. Now over here, I've got 64 divided by negative 8. Well, I know that 8 times 8 is 64. So 64 divided by 8 is going to be 8, but I have this negative that's got to stay out there. And unlike on this side where I had 2 negatives, a negative on top and a negative on bottom, this time I only have a negative on bottom. So my negative is going to stay, and that's going to give me negative 8. And now x times 1 is just x. So x equals negative 8. So like always, let's do our check, okay? Last time we said that x is equal to negative 8, but we need to solve, and well, we solved for negative 8, but we need to check over and make sure that negative 8 is actually the correct answer. So let's substitute negative 8 in for x over here. So we'll get negative 8 times, we said x is equal to negative 8, so times negative 8 plus 2 equals 66. Okay? And now a negative times a negative is going to give us a positive. So those negatives cancel. And now 8 times 8 is going to be 64. So we get 64 plus 2 equals 66. And now 64 plus 2 is simply 66. So we know that 66 equals 66. Sorry, I dropped my pen. And 66 is on both sides of our equation. Both sides of our equation are going to be equal to each other now. So we know that we did this correctly, and x is indeed equal to -8. The last question that I want to ask you is sort of a complicated one, and this is kind of a brain teaser, but I want you to think about it real quick. Can I solve x plus 7 equals y? Why or why not? Pause the video, think about it, write some answers down on a sheet of paper, and then we'll talk about it after. Okay, so this is actually kind of a hard problem, okay, and that's because unlike before we only had x was our only variable in our algebraic equations, but this time we have y, which is a second variable in our algebraic equations. Okay, and so let's try a few test numbers. One thing I could do here is I could let x equals 1, and I could let y equal 8. So I get 1 plus 7 equals 8, and then y equals 8. Both sides are equal to each other, so that's okay. So one possible solution is x equals 1, y equals 8. But there's two variables. So what's tricky about this is that there's actually more than one possible solution to this. Let's say I let x equal 2 now. If I let x equals 2, then I get 2 plus 7 equals 9, and I let y equals 9. Both sides are still equal, so it's okay, but now x equals 2 and y equals 9. So quick pause the video. What would y be equal to if I let x equals 3? So if I let x equal to 3, then I have x equals 3 plus 7. And so then I know 3 plus 7 equals 10, so then y must be 10 in order for both sides of my equation to be the same. So another possible solution is x equals 3, y equals 10. So when I have only one variable, just x, there's one solution that can make my equation true. But when I have two variables, an x and a y, then there are many, in fact, infinitely many solutions that can make my equation true. So you can solve this equation, but there's going to be more than one solution, which makes it kind of tricky.